having hecho UX, market UX of
Okay, hello everyone. Welcome to Celonis, and thank you for having the time for being here with us today. I want to start explaining a little bit why we are here. So, in the first place, we are Celonis. We are a German company that is specializing in a field that is called process mining. I don't know if you heard about it before, but process mining is like the combination of data mining and another specialty that is called business process management. That is very related with how process works. No, process mining is a very interesting field because it lets you visualize what is really happening in your businesses, in your processes, to detect inefficiencies, no, and be able to fix it. And Celonis is a pioneer here, creating two different areas in Gartner, like create two areas, first in the process mining and then in the execution management system to help companies to be more efficient, saving money, also time, and also being more sustainable. That is a very important part for us. So, and also we are like Celonis Madrid hub, and we are people that are very thankful for the tech community, and we want to give back what we receive. So we offer this space to a lot of communities to do this stuff, and also have wonderful colleagues like Andrés to share the knowledge that we have, so we can spread the knowledge and give back to the community. So thank you for being here, and that's all. And I will let that the protagonist today is Andrés to start the talk and present himself. Okay, thank you.
Thank you, Javi. Welcome, everyone, this evening. My name is Andrés. I'm going to talk about TypeScript today. It's very much related to my job. I'm an Angular developer here at Celonis. And I'm going to use this presentation. As you can see, you have the URL for the slides down there. And also, there is a link to an article that explains everything in great detail. So if you get lost or you don't understand anything, of course, you can ask me any questions afterwards, but more or less everything is written up. So the topic today is class composition in TypeScript. Well, first of all, sorry. How many of you work on a daily basis with TypeScript? Raise your hand. All right. You guys don't because you're backender. Okay. Yeah, thank you. Well, it's like any statically typed language, actually. It's a superset of JavaScript. We are going to talk about it. The agenda today is going to consist of a couple of introduction to general concepts, you know, like software design, and then we'll talk about TypeScript itself, and then about inheritance and polymorphism, and why we should avoid them, actually, what we should do, in my opinion, for each class composition, which is the topic of this talk. And in the end, we will show some code, some demo code, so you will see that I'm not lying and everything works. And it's possible to do a lot of cool stuff with this. Oh my God. Yeah. Well, before, I would like to introduce myself. My name is Andrés, and I'm a software engineer here. I was born in Madrid, but I've been working for many years in Germany. Then I came back here, and I like cinema very much, reading books, and also good food and good wine. This is my Twitter handle there. So if you want to write to me, you don't understand anything, or you just want to network with me on Twitter or X, whatever you want to call it, you can just use that, and I will follow you also back. So software design. What is software design and why is it important? There are three design concepts that we should be familiar with, right? Paradigms are the cornerstones of software design, actually, and they consist of principles. Do you guys know any programming paradigm? Anything that starts with the word programming is a paradigm. So, any paradigm that sounds familiar? Okay, we'll give an example. Object-oriented programming. So everything that's programming, that's a paradigm. And it consists normally of basically 3, 4, 5 principles. So for example, object-oriented programming consists of encapsulation, inheritance, polymorphism, and abstraction, if I remember correctly. And of course, there is many paradigms in programming, like functional programming, stuff like that. And that's only in an abstract manner, let's say. But there is also a very concrete manner for finding concrete solutions for our problems. And for that, we don't apply paradigms. We apply patterns. And in front-end, and actually there is a lot of front-end made on TypeScript, we used to apply more patterns than paradigms. So what about TypeScript? What can TypeScript do for us, right? There is JavaScript paradigms, right? All the paradigms that apply to JavaScript also apply to TypeScript. So initially, well, I heard that JavaScript was designed in 1 week, or was invented or created in 1 week, and it's, I believe it, because the first versions were really not very cool. But it was designed as a prototype-based language. That was the initial paradigm of it. And then they found out that it was good for procedural programming, which is basically like what they did for PHP, eventually became object-oriented, was also true for JavaScript, which means that every task has a function for it. Then object-oriented programming, we can do that with JavaScript. Before ES6, we could do it with constructor functions, and after that with regular ES classes that we will use in TypeScript as TypeScript classes. Then functional programming, of course, to avoid mutable data and many more things. It's actually a very, very good language for functional programming if you analyze it. And of course, event-driven programming, not only in frontend, but I made the example of the frontend with mouse events, load events. We are familiar with those. And so most of what we do with the web API in frontend with JavaScript is based on events, and those events contain callback functions. Also, asynchronous with promises. We handle with asynchronity with promises. Also contains callback functions, so asynchronous programming is also a paradigm in JavaScript. And, whoa, this pointer. Reactive programming too. For example, if we use a library like RxJS, we can handle asynchronicity, not with promises, but with streams. So we would be applying what is called the observable pattern. Okay, and then with TypeScript, well, we don't really have paradigms there. We have the JavaScript paradigms, but there is a methodology to it, which is the type-driven development. And it supports all dimension paradigms, but enhanced with static typing. That's what we can do with TypeScript. And then the TypeScript features, what they do is they create something called the interface-based programming paradigm, which is a paradigm itself. We're talking about, what was this thing with ports and
Hexagonal architecture.
Hexagonal architecture. It's more or less the same, actually. Criteria. So when we have a TypeScript project, what is the criteria to apply? What paradigms we apply to split our code, to organize our architecture, right? In backend, we can say that we can apply just any paradigm, actually, because backend is related to data and things that are, let's say, external to the language. And so we will actually skip backend for the topic of today, because it just can apply any existing paradigm in backend, in any backend language. But frontends maybe should not follow those backend paradigms. That's what we are going to talk about, why we shouldn't use the same paradigms as in backend. Most frontends are component-based. We use a component-based architecture nowadays. It doesn't matter if we are using a single-page application or a multi-page application. Normally, nowadays, all of them contain components, even React server components nowadays, and things like that. So the business logic that doesn't relate to components in frontend, right, aligns with the backend. You use the same logic and you model the same things and shape them in the same way as in the backend. So you don't have much of a choice there. You don't decide anything. But the components should apply these patterns and not paradigms, because they contain, they have like its own nature, right? They have a template with, you know, some visual thing and some behavior to it, which is called the component logic. So we should not apply paradigms because components are very small and paradigms don't apply to it. It's patterns what applies to components. So let's talk about a little bit about inheritance and polymorphism. There are two main core principles of object-oriented programming, and they are by default used in almost every project that I've seen in my life. But we should question that, I think, especially for front-end projects. So the first thing we should know in any project, doesn't matter front-end, back-end, any language in the world, there's one principle that doesn't belong to a specific paradigm. It's called DRIVE. Are you guys familiar with DRIVE, this acronym? What does it stand for?
Yourself.
Don't repeat yourself, correct? It means just don't copy and paste the same code in different places of your software. Don't do that. What you should do is centralize the snippets and then retrieve them from different modules, right? Be an animal. Normally, when we learn object-oriented programming, we are, using this animal example. This is a TypeScript abstract class, as you can see here. It's for an animal, and it states that an animal always makes a sound. It doesn't provide the implementation of this make sound method. It says that there is going to be in the children classes some method called make sound, and this make sound will do something or will make a sound, right? And then there is a move method which is implemented there, so every animal moves. Well, it's true. So the dog moves, and then it makes a sound, it barks, actually. Then there's the cat, it meows. So if we instantiate those two classes, the output is really what we expect, right? So essentially it looks like it works, right? But what if you are any animal? Think of snakes, for example. Normally, humanity do not like snakes because most of them are poisonous or they are too big and they just strangle you, they kill you. But they are just sweet animals, they move, and they do not make any sound, okay? They are very, very silent, these snakes. So what do we do about them? Because this abstract class doesn't apply to the snakes. We need to introduce in between another abstraction called noisy animal and another for silent animal. So what happens there? That would create two very, very, very similar chains in the hierarchy, and with many subclasses that will have a lot of methods in common, a lot of things that you don't want to repeat yourself. So we should avoid abstract classes and we should avoid inheritance. They can only be extended by one other class, and that's not the level of flexibility that we are looking for in a component-based architecture. And also, they break the Liskov substitution principle. That is one of the 5 solid principles that we apply to almost every project. And this one is actually very good. And it's what we talk about the snakes, any subclass should replace the superclass without breaking the program, and the snake breaks it. So it's breaking also the Liskov substitution principle. And hierarchy change become extremely complex sometimes. So polymorphism, what we talk about with the make sound method, may involve also runtime method resolution. So basically the JavaScript engine will have difficulties trying to choose which of the implementations of the make sound method you have to do in every moment during the runtime. So that's also a problem. It can affect performance, and code can get very tricky to debug and to test. So what do? We need another mechanism, not inheritance, certainly. And what we do in this case is composition. But in our project, we always use or almost use frameworks, right? I mean, there are not so many projects in the world, maybe GitHub who implements vanilla JavaScript, but in all the projects I've seen, you implement React, Angular, Vue, Svelte, you name it. You use a framework. So composition versus inheritance. It offers a more flexible approach as I've mentioned, and it follows the mixing pattern. Any of you familiar with the mixing pattern? Cool. Mixins, sorry, this pointer just too much, are objects that can add functionality to other objects and classes, but without using inheritance. That's important. So they're actually the solution we are looking for to provide composition. So this pattern is widely used in front-end frameworks, the mixing pattern, or it was used some time ago, depending on the framework, actually. The best way to apply it, also in my opinion, this is a personal opinion, of course, is with TypeScript classes. I think it's wonderful. They really provide everything you need to create composition. So what frameworks do not do TypeScript classes? That's important because you need to know the limitations. Depending on your project, if you need to do a project with, I don't know, Next.js, which is a framework on React, you have to know that you cannot do this because React and React-like frameworks declare functions, not classes. But they used to do something called higher order components. I don't know if you have heard of them. Maybe it's an old thing, but basically they were functions that take components as a parameter and return other components. And that's composition. But they stopped using it, and now they use React hooks, because those hooks were usually to store stateful properties, and now it's done with the hooks. So, Vue, what happened with Vue? To do TypeScript classes with Vue, which was possible in version 2, you needed to use third-party library. They have disregarded this practice. It's considered to be a bad practice as per Vue version 3. They don't do it anymore. So Vue is not an option for this. You can do whatever you want. Svelte. Well, Svelte is very, very, very special. It has a very, very particular syntax with pseudo HTML script tags and declares loads and events and blah, blah, blah. Nothing that looks like a class at all. It's not possible. What frameworks are actually doing TypeScript classes? All the ones that are created by people who work for Google or who have previously worked for Google. Because Stencil was created by a guy who, by the way, he's from Madrid and he worked from Google. I forgot his name, sorry. But he's extremely good, and now he created Quick Framework, if you know about it. And Stencil is declaring classes and decorators and everything we are going to see in a moment. There is Lit. By the way, Stencil and Lit are not really frameworks. They help us to declare web components, but they are not really frameworks. However, it's been proven that you can do very, very powerful web applications with them. Like, for example, here in Spain, BBVA is making a huge project with Lit, and they are like the biggest Lit project in the world, actually. And then, of course, there is Angular. Angular is the one that pioneered TypeScript because its core was made initially written on TypeScript and was recommending TypeScript right from the beginning. Even you could write it in the version 2 in Dart or JavaScript. TypeScript was always the best choice. So these three options we have, or vanilla TypeScript, you can also do that. So I wanted to mention this because Angular actually provides an API for directed composition, and with it you can actually do composition with TypeScript, but the problem is the kind of composition we are doing and we are going to do is through mixins and decorators, and that means that we create a mix of several classes together, and that mix is instantiated at once. But in this case, there is a host directive. And by the way, in Angular, if you are not familiar, a directive and a component are exactly, and I mean exactly the same. Just the only difference is that component has template and directive doesn't. And then what it does, it instantiates directives separately from the component, but it combines them into some sort of composition. The problem is, if you want to use a property declaring the directive, like this menu open here, you will have to inject the actual directive and redeclare it into a local property of the component. So what's the problem here? We are not removing the boilerplate, and by not removing the boilerplate, we cannot stay dry. So they are great for, I don't know, combining different component behaviors into one component, but then if you want to, let's say, access one behavior from one another directive, like here, you are going to encounter this problem, so I actually prefer to do what we are going to do, mixins and decorators. So the only two effective ways of doing TypeScript class composition are these two, and mixins are explicitly designed for composition, whereas the other ones are more inclined to annotations, meta programming, but actually you can achieve the same thing. If you put a decorator on top of a class, you can do the same thing as with a mixin class. We're going to see that, don't worry. Okay. And decorators were really a bad practice not so long ago, actually. They were disregarded by Google because they were in TypeScript an implementation of a TC39 proposal that was in stage 2. But as per TypeScript 5, Polines, as per TypeScript 5, you can implement stage 3 of TC39 process. I don't know if you are familiar with how JavaScript features get approved. There is an actual committee here in Europe, in Zurich, I think. There is the ECMA International Association, and they have something called the TC39 process, and it contains from 0 to 4 stages. And 3 is actually almost the final one. It just needs some refinements. And then when it reaches stage 4, it means it's approved. And you can use it in the latest ECMAScript specification. So look at decorators. They are currently at stage 3, and it's very much promising that they're going to be approved very soon. And with TypeScript, you can do like implementing this next feature that is going to come next already, but only if you are using TypeScript 5. So do not use decorators if you are using any lower version than 5, please, because you will encounter some consistency problems. The stage 2 and stage 3 implementation of decorators are totally different. Okay, so let's take a look at some code if you want. I have created this repository. This is a link. Maybe I can copy paste the link of the whole presentation into the Meetup platform later, but it's very simple. It's in my handle for GitHub, and then it's TS class composition, so that you can play with this code. Let's see. How well do you see this? Should I make it bigger?
Yeah.
All right. No, I have problems with the microphone. All right. Well, so let's see. I'm going to make a build of the first example. All right. And then we are going to take a look at it. Maybe I should make it smaller, actually. This is a self-invoke function kind of replicating the behavior of an app, in front end. The first thing we see is the type constructor, this here. It is very important, both with decorators and with mixins. You will use this type a lot, because otherwise, if you try to return from an extended anonymous class in TypeScript, you will get a compilation error. It will not let you compile the code. So it's very important. And then for decorators, what we do is we create an interface for every extra members. By members, I mean either properties or methods from the class that are going to be added to the decorated class. Okay, so we are going to create a class, a decorated class that contains a components property. And by that, we are going to introduce a map of components that are going to contain a value telling if the component in this app component is going to be rendered eagerly or lazily, right? And we're going to do it composable. We don't want to declare it directly in the app component, right? Let's see. And then this is the first decorator, the rendering decorator, right? So what is it? Basically, it is a function that is going to return a class. Or let's say a function that returns another function that returns a factory, a function that returns a factory function. That's what it is. Factory functions are functions that return objects for classes. So what we do here is we can, this is of course optional. Decorators can take configurations into it, but that's normally what we do. Actually, I haven't seen many decorators that do not contain any configuration or any default configuration. And then it's going to return a function that is going to expect two parameters. One is the base. And the base is basically, is the class that you are decorating in this case. We're going to see that that can change, but that would be the base. And then the context. And the context can contain information about that base, about if it's of kind class or not. For example, as you can see here, we are checking this out because decorators can not only decorate classes, they can also decorate methods and properties of the class. But we are going to focus only on the classes because that's what we do when we want to do composition. So, any questions so far, by the way? Okay. So then, you check that it's actually a class. Otherwise, you just return the base value. And if it's a class, what you do is tell, okay, I want to extend the base class and then add these components property to it. And then you go to the app component here and decorate it. And you pass the components to it. It's very simple. I'm pretty sure you have sometimes seen this, especially if you are working on an Angular project. And then you have to add this interface here that says that this app component is extending from the compose app because otherwise TypeScript will yell at you and will not let you compile. So I have created this very basic class like properties, property method, returns method. And then we instantiate it here. And we are going to log some values to double check if it actually, composes the class that we want to do. So we know that the component has a property and a method. But then we want to check if those components, the one that is loaded eagerly and the other one lazily, are actually there. So let's check it out. I think it's 8080 the port that I use. All right. So as you can see, it's true. We get the property, we get the method, and we get this here. And as you can see, this is not written in the app component. This is the most simple example, but we can do it like much more complex actually. So let's say, apart from this decorator, we want to add more. Like for example, you remember the directives API from Angular that I mentioned, telling if there is a menu open, to open the menu or not, or toggle the menu. Those we can also add through a decorator, and then we can add a state. Don't pay attention to these interfaces. The state that I have provided is pretty much similar to what they do in NGRX, but in small. So if you don't understand this code, don't panic. Just know that there's going to be an observable that we implement with with RxJS, and that is going to retrieve an state for us. And this is the menu decorator, so it's doing the same, checking if it's a kind class, and then we return the class extend from the base. And we put them like here. So we put one on top of another, like piling them up. What is interesting here is basically the only decorator that will have access to the decorated class when we are composing is this one here. And another thing that is very, very important when you are doing this that you should understand is that those decorators are basically as functions, and they are evaluated top to bottom, but executed bottom to top. So if you implement any console logs, they will be shown top to bottom. But this code here, the one belonging to this menu decorator, will be the first one to get executed. All right. So we have implemented some extra properties, and we want to see if we are actually getting them added to the app component. So Let's see. All right. Then I will. It's true, right? Because what we are doing in the logs is, if you see, well, we are subscribing to this state and we are logging here, but then also we are getting the menu open if it's open or not, and it's by default false, but then we are toggling it and it should be true. And then if we come here, we see that the properties are there, that is working, and that we are executing them from the app component instance and not from any other place of the code, you know? So we are basically, in this app component, combining several classes into one, and that's composition. That's what we couldn't do with inheritance, and that's why I think this is interesting. And here you can find, I don't know how long I have spoken, you have an example for mixins. We are gonna try to do exactly the same. So basically, if I reload, we should get exactly the same console logs, but with mixins, and we are going to see if there is any difference. Well, there's one. First of all, we don't have this composed app interface. We are decoupling the extra properties and methods into 3 different interfaces, one for each decorator, and we apply to them. Like for example, here the rendering one is applying the constructor for the rendering app. This one is the one applying for the state app, and this one is the menu mixin that applies the one for the menu app here. And it's doing exactly the same, but what we see here is basically what React used to do with these higher order components. We are getting a component, we pass it as a parameter into a function, returning another component. So basically, it's written like this. It's the same, you know, the first one that is going to be evaluated is this one, but it's going to be the last to be executed. The first one to be executed is this one, the menu mixin. The only difference is none of them have access to the base class, and I mean this one, this app component. None of them will have access to it. So we can do the same, but there is a crucial difference between decorators and mixins. They can achieve the same if we put them on top of a class. But here, what we do is basically we pass an empty class to the deepest mixin. And that's how it's done. If we come here and we reload, you see, it's exactly the same output. We have done exactly the same with mixins and with decorators. And now finally, and you know, I will finish the presentation with this. We can have edge cases, cases where none of what we have shown applies. For example, let's say we want to define a web component when initializing the mixin. I don't know if you're familiar with web components. Web components have you know, a lot of boilerplate to be provided for every web component. Actually, it's not so easy to declare them. But for that, we have lit and stencil libraries so that they can help us build them. But if we want to do that, you know, just from scratch, the first thing you need to do is to access this window, custom elements global object, and then define the custom tag here for the new element, which is going to be a web component, and pass to it the class that will contain the functionality of that web component. And if it's the app component, in this case, what we will need to do, let's see. Ooh, so it's telling us something, right? Unable to resolve signature, blah, 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 blah. And it's because basically the app component has to extend from HTML construct. So let's see what happens if we do this, right? This is the example too, so it's with decorators, not with mixins. Mm-hmm. All right. It apparently works, right? But let's see what happens if I want to really check if that component has been registered in the DOM. Just a second. And this was the tag that I have. The tag that I have used is custom tag. All right. It has actually created a web component, but check it out. Not to the app component class, but to this other one, which is, if you see, is the rendering one, the rendering decorator. So this is wrong, right? Because we are registering a web component, but not the class that it belongs to. What we should do then, you think of it, is to leave the decorator just on top of the app component class. Let's do that. We build again, and then we reload again. And now we get an error. So what's the problem here? It says illegal constructor. It's very, very difficult to understand what this means because there is no documentation to it whatsoever. And if you try to look for it or ask for it or ChatGPT or whatever, it doesn't really tell you the answer. The way I understand it is, okay, as I told you, this is evaluated from here to here, but the first one that is getting executed is the one at the bottom. Is the one we have to use because it has access to the app component. It's the only one that can have access to that. But the problem is, by the time you execute there and define the web component, the mixing is not finished. And it needs to be app component, but with the other decorators mixed up into it. So if it's not finished, it's going to throw this error. What do we do? In this example, we have the solution. This is a combination of this custom element decorator and the mixins. And if you do it this way and to the deepest mixin, instead of passing this empty base, empty class, pass HTML element, this one will work. Let's see. And then let's see is the component register, and it is, class super is HTML element, as you can see here. And app component is the one that we want to use the functionality from. So it is really doing what we expect to do. So what would be then the conclusion? Use mixins for class compositions that involve either adding or replacing class members. However, do use decorator for edge cases that it may involve initializing, like the example that we have seen, or modifying functionality. Because we can actually take a method that exists, for example, in the app component, like this method called method, and modify or add functionality on top of the existing functionality of it. That we cannot do with mixins. So decorators are more powerful, but they are not really designed for class composition. They are designed for anything you want to do. And that's basically it. I hope you have liked this talk. I hope you can check the code and see for yourself how it works. And I hope if you have the opportunity to work with a TypeScript project, you can do good use of this. I don't know. Thank you so much for coming this evening.
Maybe question?
Of course. Sorry, I forget always about that part.
Isn't the same to extend a class, or mix a class using object that assign?
Object assign. No, it wouldn't be good.
It won't have the same result, just mapping out the same methods.
You could do it with extending, like inheritance, then you can use object assign. But how do you do composition with many classes with object assign? I don't think it's possible. I haven't tried.
You change all the object assigns. I mean, it's out.
Yeah, maybe it's possible. I don't know. I haven't checked. Yeah, maybe it's true. I don't know. But I think TypeScript provides, like what we were talking about today, that it provides a very clear syntax, like for readability at least. I understand better this code than declaring functions or assigns or things that are more tricky. I don't know. I will check that.
In a more practical question, do you find your experience with TypeScript better with decorators, with the native decorators of TypeScript, or with mixins? Because personally, with mixins, I have a horrible experience with TypeScript.
Well, let me tell you.
Beginning with having to have this boilerplate constructor type that no one decides to publish on NPM, by the way.
I'm actually very crazy when I do these things. You know, I'm not really afraid of things that are not being approved by the ECMAScript International Association. In my previous project, I will not say for what company, I made the whole architecture of the biggest project of the company to rely on a decorator. And I mean a stage 2 decorator. They were actually more powerful than the stage 3 ones, because in this stage 3, in the decorator, you have access to the base class prototype, all right? But you don't have access to the base class descriptor, which you can use to change, for example, if the class is enumerable or configurable or stuff like that, that you were able to do with the previous version of decorators. But we all knew that that was too powerful and that was never going to come out. I don't know, there are solutions to do the same, but I don't know, I really like decorators because you can just do anything with them, you know? But I have to acknowledge that, I don't know, for example, Angular material uses mixing classes since the beginning, and they work, you know? But if you take a look at the lead project, and that's in the article actually, they use decorators to do exactly the same as I have shown in the example in smaller thing. So they use decorators to add the tag of the web component and blah, blah, blah. And they use mixins for different things. So they are very much aware of this distinction of them. I think, I think decorators are too much power. But I have really much have fun with them in my career. What question? Should we stop the recording?
Okay, so thank you so much. We are going to prepare the food for networking now. So you can stay a little here, or you can go to the kitchen below. Like there will be some drinks and some food for you, and the thing that you can continue asking Andrés or continue asking, like knowing each other. Also, you can ask things for Celonis. There are some Celonis here also, and I hope that you have enjoyed. Thank you for being here, and I hope that we can see you again in our next meetup, okay? If you need, bathrooms are here in this wall, and if you need to exit the building, now we will need to exit for another door, and it's a little more difficult, so you can ask me or anyone from Celonis, and we will go with you to the exit, okay? Thank you so much.